Good morning, Year 11s. I know that we've put some notes and textbook stuff and videos up for you, but I couldn't resist trying to explain this to you myself. So this week we're looking at covalent bonding. So far, next slide. So far we have talked about metallic bonding, which is between metals and other metals. So this one here. Metals being over this side of the periodic table, they've got 1 or 2 or maybe 3 electrons in the outer shell. So they form lattice structures and the electrons kind of don't know which atom to stick with, so they can flow through the substance and so they can conduct electricity, they can conduct heat. We've looked at, let's get another colour. We've looked at ionic bonds, which is between your metals on this side and your non-metals over here. And because your non-metals have got an almost full valence shell and your metals have got 1 or 2 electrons in the valence shell, the non-metals can pull the electrons away so that they can get a full outer shell, and then the particles being charged will just attract together. But this week we're looking at covalent bonding, which is between non-metals and other non-metals. So between the substances that are on the right-hand side. And because most of them have an almost full valence shell, none of them has got the strength to remove an electron from another atom. They've all got similar electronegativity. None of them is quite strong enough to fully remove an atom. So they kind of, an electron. So they kind of fight over it. They share electrons. So here's some notes about covalent bonds. So the electron pairs are shared so that all atoms have got complete valence shells. Covalent substances have got low boiling points because the attraction between molecules is fairly weak. So don't confuse that with the attractions within a molecule. So I've got 2 little carbon dioxide molecules and they're not very well attracted to each other. They're gases, they'll kind of float around. They're bonded strongly. So within the carbon dioxide bond, the carbon and the oxygen are bonded quite strongly together, but they're not very strongly bonded to the other carbon dioxide molecules, which means they can easily melt and turn into a gas, right? That doesn't affect the bonds within the molecule. So in a physical reaction, I wrote that down somewhere. Oh yeah, so the intermolecular bonds, which is the bonds between molecules, they're broken in a physical reaction, but the intramolecular bonds, the bonds within the molecule itself, are not broken in a physical reaction. They're only broken when there's a chemical reaction and those bonds can break apart. So you will be asked to distinguish between inter and intramolecular bonds. So make sure you understand the difference between those. And covalent substances don't conduct electricity in any phase because the electrons can't move around. The electrons are all tied up in these shared bonds. All right. The next bit, single, double and triple bonds. So single bond, you get 1 pair of electrons, 1 from each atom. In a double bond, you've got 2 pairs of electrons, and a triple bond, you've got 3 pairs of electrons. You need to be able to draw the structures. So we're gonna have a go. Hydrogen has a single bond, and I know this because there's 1 outer electron in each hydrogen. So we've got this hydrogen comes with 1 electron, this hydrogen comes with 1 electron, and now we've got a pair here. And they've both got 2 electrons in their outer shell. So you can draw that in 2 ways, and you'll be asked to draw it in 2 different ways. You can draw it like this, or you can draw it with the bond as a line. Okay, so this is a dot diagram. Pretty hard to write on that screen, sorry. And this is a Lewis structure with lines. And sometimes you'll be asked to draw all of the outer electrons So make sure that you read the questions carefully. Sometimes you're asked to draw all of the dots and sometimes you're not. Chlorine will do the same thing. So chlorine has 7 electrons. Let me pause this so you don't have to watch. So each chlorine atom has 7 electrons, and the overlap here is that 1 pair there. So you can either draw it like that with the dots, or you can draw it like this, where 1 chlorine is bonded to the other by a single bond. All right, let me rub that out and start again. Okay, so I knew chlorine would make single bonds because I knew that there was 1 empty space in the valence shell. If I move 1 element to the left, so let's go to oxygen. So I know that oxygen's got 2 spaces in its valence shell. It can form a double bond, and but from one oxygen to another, it does form double bonds. So 1, 2, 3, 4, 5, 6, and you've got your other oxygen over here. 1, 2, 3, 4, 5, 6. So they're sharing 2 pairs of electrons around there, and you can draw that as O with 2 lines and another O. Okay. Now they're not always going to have double bonds, oxygen. So water, for example, is an oxygen with 2 hydrogens. We've got 1, 2, 3, 4, 5, 6. We've got a hydrogen over here, putting an electron into that shared pair, and another hydrogen over here. So those are both single bonds. So you've got your oxygen, you've got that hydrogen there, and you've got that hydrogen there. Okay, I will do a triple bond. Hang on. Nitrogen is an element that has 3 spaces in its valence shell. So here it is here. It's in group 5. Is it group 5? Group 15. So it's got 3. It's got 5 valence electrons. So it'll have a pair here. It'll have 1 here, 1 here, and 1 here. And then it can join with, I don't know, some hydrogens, can make 3 single bonds. Or it can join with another nitrogen. So it's got the lone pair there. So this nitrogen's got a lone pair there, but the 3, 1, 2, 3 from there, and 1, 2, 3 from there, they're sharing those 6 electrons, and they've got the other 2. So now they've got a full 8 in their outer shell, and you draw that like this. Okay. So I just had a look in your book, and one of the questions in there is you're asked to draw tetrachloromethane. I think that's what it says, tetrachloromethane, and it tells you that is CL4. That's tetrachloro, it's got 4 chlorines, and with the C makes it methane. So carbon has got 4 spare electrons, so it can make up to 4 single bonds. It can also make double, triple bonds, but it can make 4 single bonds, and here you've got 4 chlorines. So you start by drawing all the electrons in the carbon, and you would probably start by drawing all the electrons in the chlorine as well. I sometimes get a bit slack and don't put all the electrons around the outside, but please don't copy that when you're doing your tests. 1, 2, 3, 4, 5, 6. Those are supposed to be X's. 7. And then there's another chlorine down here with 1 there. 2, 3, 4, 5, 6, 7. And that would be tetrachloromethane. Now, the only other thing I want to talk about is in your book, it goes a little bit into the shapes of molecules. And there's a whole chapter on that later on, but the shape of the molecule has got a lot to do with the bonding, the bonding pairs. So for methane, which is CH4, let me write that down. I've got this thing. So you've got your carbon there, and it's not two-dimensional. You're drawing two-dimensional, but it's actually a three-dimensional shape. And there's a theory, the VESPA theory, which is valence shell electron pair repulsion, which just means that the pairs of electrons around the outside of the central atom will get as far away from each other as possible. They repel each other. So you end up with 4 pairs of electrons around that carbon. Let me draw a quick picture of that. Carbon, 1, 2, 3, 4. Hydrogen. Right, so carbon with 4 hydrogens around it, 4 pairs of electrons, and they repel each other so that the methane molecule will end up with a tetrahedral shape like this. It's symmetrical. And knowing what the electron pairs are, you will need to, later on, you'll need to be able to describe the shapes of molecules. And I don't think we're going to ask you too much about doing that in this chapter. But for the water one we did before, let me just rub some of that out, make some room. I should have paused the video for that. There we go. All right, so we've got H2O. Oh, that's an eraser. H2O, 2 hydrogens and an oxygen. So you've got your oxygen here. It's got 6 outer electrons. 3, 4, 5, 6. You'll have a hydrogen here and a hydrogen here. So that molecule still has 4 pairs of outer electrons, but only 2 of them have another atom attached. So these 2 kind of might as well not be there. You can't see them. They're just bonding pairs of electrons, but your atom is still going to be this shape because there are still electrons over here somewhere and still electrons over here. So if you're not drawing those lone pairs of electrons perhaps, or you're not representing them, but they're still there. So the hydrogens are going to be on 2 of these pairs of electrons, and the water molecule ends up being that bent shape. So that's that. But HCl molecule, for example, hydrogen has 1 outer electron, chlorine has 7, 2, 5, 6, 7. I should have done dots for those. Chlorine's going to have 7. You're going to have, regardless of what else is going on around the outside, these electron pairs are all going to be there, but the molecule itself is just the hydrogen and the chlorine, and all this other stuff's, not in the picture. So you're going to end up with something that's that's a straight shape. So we'll go into that in more detail in chapter 12. Don't worry too much about that now, but do have lots of goes at drawing the Lewis structures. Work through the chapter questions. Message me if you get stuck. Have a lovely week.